channel. This is T. Aftab Hussain from third year mechanical. Today my topic is about metal cutting theory and chip formation. The subject name is machining processes. Metal cutting theory and chip formation. Introduction to metal cutting. Metal cutting is a manufacturing process where material is removed to shape a workpiece. It involves the relative motion between a cutting tool and the work material. Understanding the theory behind it is essential for optimizing machining operations. Types of metal cutting processes. Here are the some types of metals: steel, iron, bronze, brass, aluminum, copper, chromium, gold, lead, silver, magnesium, tin, nickel, titanium. Common processes include turning, milling, drilling, and shaping. We already know that we have the lab in machining processes: turning, milling, and drilling and shaping. We already did in the we already uh, uh, did in the lab. Each processes involves different tool workpiece interactions and cutting conditions. The choice of process depends on the desired shape, accuracy, and production value. Basic principles of metal cutting. Metal cutting occurs when the cutting tool removes material in the form of chips. The cutting process involves shear deformation in a localized zone called the shear zone. The tool's geometry and cutting parameters significantly influence the efficiency of cutting. Cutting tool geometry. Key tool angles include rake angle, clearance angle, and cutting edge angle. Proper tool geometry reduces cutting forces and improves surface finish. Tool wear and failure are affected by the tool's design and cutting conditions. Mechanics of metal cutting. The cutting process involves the conversion of workpiece material into chips through shear. Cutting forces consist of shear force and normal force acting on the tool. These forces influence power consumption, tool wear, and surface quality. Chip formation mechanisms. Chip form when the work material shears off under the action of the cutting tool. Various types of chips include continuous, discontinuous, and segmented chips. The mode of chip formation depends on material properties and cutting conditions. Types of chips in metal cutting. Continuous chips are smooth and form under stable cutting conditions. Discontinuous chips are fragmented and occur with ductile or brittle materials. Segmented chips are periodic and often result from specific cutting parameters. Factors affecting chip formation. Work material properties like hardness and ductility influence chip shape. Cutting speed, feed rate, and depth of cut significantly impact chip type. Tool condition and cooling methods also affect how chips form are expelled. Chip breakage and control. Proper tool design and cutting parameters help control chip shape and size. Chip breakers can be used to facilitate chip disposal and prevent entanglement. Effective chip control improves machining safety and efficiency. Heat generation in cutting. A significant portion of the energy in cutting converts into heat. Heat is generated mainly in the shear zone and at the tool work interface. Managing heat is crucial to prolong tool life and maintain workpiece quality. Effects of cutting parameters on chip formation. Increasing cutting speed can promote continuous chip formation. Higher feed rates tend to produce thicker and more segmented chips. Adjusting the depth of cut influences chip size and the heat generated during cutting. Material removal rate and surface finish. The rate the rate at which material is removed affects chip size and formation. Smoother and more controlled chip formation results in better surface finish. Optimizing cutting parameters balances productivity and tool life. Advanced topics in chip formation. Modern techniques involve simulation and modeling of chip formation. Understanding secondary shear zones helps improve cutting efficiency. Innovations include cryogenic cutting and advanced tool castings to enhance performance. Summary of key concepts. Metal cutting involves shear deformation and chip formation governed by tool geometry. Chip types and formations mechanics depend on material properties and cutting conditions. Controlling chips and heat generation is vital for efficient and high quality machining. Reference Kalpa Jain and Skind Jain PK 2009 Governor. And thank you for giving this golden opportunity.